the aquifer to learn something about its physical and biological properties. So that's what I wanted to address here. We refer to this as physicochemistry because it represents both chemical and physical features of the groundwater. When we look at the relationship between some typical physical-chemical variables, we can see that as you cross the 19 wells that make up those two transects, and these are annual averages over 5 seasons, you can see that as the dissolved oxygen declines, the pH declines in a relatively tight relationship, given that we're crossing 6 or 7 kilometers of distance and integrating 4 or 5 seasons. The idea of using percent saturation, here you can see the same relationship between dissolved oxygen and this time electrical conductivity. It's a measure of the total amount of ionic materials in water. As the dissolved oxygen declines, more stuff gets dissolved in the water. The value, or rather the unit used for dissolved oxygen here is percent saturation. That's saying if you just had water and an atmosphere in contact, how much oxygen would you expect to be in that water just based on physics? That would be 100% saturation. Anything deviating from that reflects other processes driving you off of saturation. So it's corrected for temperature effects and for pressure effects. And as it turns out, temperature doesn't really do a lot. Heat content. Here's the pH. Right? That comment was out of order. Here's the third set of correlations. As the pH declines from 8.5 up to below 7.5, the electrical conductivity increases. So a pH change of 1 unit may not seem like a lot, and the pH numbers are kind of sloppy. But remember that pH values are